Okay, so talk to me about, we're talking about isosceles and equilateral triangles. Talk to me about what an and let's do equilateral. Talk to me about what an equilateral triangle is. All sides what? Are congruent or equal measures. That's right. And what about an isosceles triangle? Two sides. Or just two? Or more. That's right. So two or more. All right. But today, for this specific example, question?
How can it be two or more?
Two sides congruent would be isosceles, and three sides congruent would also be isosceles. But it would also be equilateral. Yep.
So equilateral triangle is an equilateral and isosceles?
Yes.
Oh.
That's correct.
Wow.
So today, for this example, I am just going to do an isosceles triangle with two congruent sides. So go ahead and kind of exaggerate that in your picture. Okay? So if I draw a triangle that is isosceles, I want two sides to be congruent. And so I mark those with little tick marks to show that they're congruent. Those are called the legs. So this is a leg. This is a leg. So over in your vocabulary box it says leg of an isosceles triangle. The legs are the two congruent sides. And they actually create a vertex angle. So over on our picture, this angle right here is the vertex angle. So we have two legs of the isosceles triangle, and then we also have the base. Now, you might say that the base is on the bottom, but remember, this triangle can be rotated, so it's not necessarily going to be on the bottom, but it's going to be the third side in the triangle that is not the legs, basically. So it does not have to be congruent to any of the others. And then lastly in our vocabulary chart there we have base angles, okay? So we have the vertex angle and then we have the base angles. And those are the two angles created by the base and a leg. And why do you think I marked those with arcs? Yep, they're congruent. Questions about that? Okay. Let me see something here for just a second. Hold on. Okay, so we have two theorems that we can use with isosceles triangles. The first one says if two sides of a triangle are congruent, then the angles opposite of them are congruent. That's just telling you or giving you a theorem as to why the base angles are congruent. So this is telling you that if the legs are congruent, then the base angles are congruent, so angle B is congruent to angle C. Now when we get to proofs, you are going to have to state this. So I'm going to give you some symbols that are going to make this a little bit easier. Okay? So if the legs are congruent, then the base angles are congruent. So on your homework or on a test or a quiz, it says to explain your answer. That would be a good explanation. And what does a converse do? Yeah, it flips it, right? It's the opposite. So if two angles of a triangle are congruent, then the sides opposite of them are congruent. So that tells you that the legs would be congruent in this case. So AC would be congruent to segment AB. So if we write that with symbols, again, we use the converse, we flip that. If the base angles are congruent, then the legs are congruent. Questions about that? Okay, so let's look at this in some examples. Example number 1 says, find the measure of angle L. What would the measure of angle L be? 52. Why? How do you know? That's right. If the legs are congruent, then the base angles are congruent. That's your reason. That's your explanation. That's the why. But what if I asked you for the measure of angle M? I didn't ask you for the measure of angle L. What if I asked you for the measure of angle M? Would you still have needed the measure of angle L? Yes. How do we use it to find M? That's right. There's 180 degrees in a triangle, right? So 180 minus 52 minus 52. Well, 52 and 52 is 104. What would you get if you subtracted 104? 76 degrees. Okay? So again, they asked for the measure of angle L, but we were able to use that to find the measure of angle M also. Okay. Example number 2. Find the value of x. How do we do that one? X plus 3 plus 12 equals 180. Do we agree? Anybody? Agree? Disagree? X plus 3 and 12, what are those measures of? The sides? What is 180 the measure of? What in the triangle? The degrees in the triangle. Do we measure sides with degrees? No. So does this equation make sense? No. It is a very, very, very common mistake, but this, don't erase it, cross it out. I want that on your paper crossed out so you can see that that is not an option, because that mixes sides. This is angles. Those don't mix. So how do we fix the equation? What is the equation going to be? X plus 3 equals 12. Why? Why are these equal or congruent? How do you know? It wasn't marked. That's right, because the angles are congruent. If the base angles are congruent, then the legs are congruent. They wanted us to find the value of x, so I'm going to subtract 3 from both sides, and I get x equals 9. You could plug that back in and verify that your answer is correct, so you would have 12 on each side, which makes it an isosceles triangle. Any questions? Okay, go ahead and try those 3 checkpoints there, but make sure that you are saying why. You are explaining why you are able to find that value. Okay, find the value of y in number 1. What'd you guys get?
50.
Why?
50 equal side equals equal measure angle.
That's right. Okay, number 2. What'd you get for y?
9.
Why?
Equal congruent equals equal size.
Yes. And number 3, what equation? Make sure you are showing your work on your homework. If you don't have an equation, you don't get full points. So what is the equation?
Y plus 4 equals 16.
So if you solve that, you subtract, you get y equals 12. Why? With me? Okay. So let's talk about equilateral then. If a triangle is equilateral, so all of the sides are equal, what else did you guys know about that? The angles are also equal, so it is also equiangular.
How come you wouldn't set them through
What's that?
Why wouldn't you set them through
Because those are sides, those are not angles. Does that make sense?
How many more notes?
Okay. So, for equiangular, we would have angle A is congruent to angle B is congruent to angle C. And guess what? The converse of that works as well. So if they're equiangular, it's also equilateral. So AB would be equal to BC and also equal to AC. So, find the length of each side of the equiangular triangle. But they give us sides. Well, because it's equiangular, we know it is also equilateral. So if, check it out, equiangular, then equilateral. So that means these sides are congruent or equal. So we shall set them equal. To solve, we are going to subtract 2x from both sides and we get x equals 10, but that's not what they asked us to do. They asked us to find the side length, so we need to plug it back in. Here we would have 3 times 10. Here we would have 2 times 10, which is 20, plus 10 is 30. So far we're good. What is the length of the third side?
30.
Perfect. Now, my last question to you is how many degrees? What is the measure of angle R? What is the measure of angle Q? And what is the measure of angle T? I know they didn't ask you, but what are they?
30.
No, not 30, because 30 plus 30 plus 30 would only be 60. Yes, 60, 60, 60. How'd you figure that out? 180 divided by 3 equal angles would give you 60 degrees for each. That will be true for all equiangular and all equilateral triangles. Questions?
Nope.